Okay, so we're now going to look at word problems with 1.5, solving problems. So the key thing is when solving real problems, we can solve them as if they're linear, but you have to check and make sure that the answers make sense for the situation. So let's say we have a scenario of money and you have a certain number of coins. If you end up getting one of your variables to be a negative number, you know that that doesn't make sense. You can't have a negative number of coins. Therefore, that will let you clue in that you've done something wrong in your work, and you can go back and look at why you have a negative answer when it's not possible. So let's look at a regular money question. Tim is counting up his change to put into rolls. He has $3.80 in quarters and in nickels, and he counts 32 coins. How many are nickels and how many are quarters? So I want you to think about this question, create your let statement, and create your first two equations. Pause the video and come back. So now that we've come back, you can see that we have our let statements of Q being the number of quarters and N being the number of nickels. And your two equations are that Q plus N will add up to 32, and the value of 0.25Q plus 0.05N will equal $3.80. So we can first get rid of our decimals by multiplying the second equation by 100, and then we'll see that we end up getting our n being a 5n, so let's multiply the first equation by -5 so that we have the same coefficients on n. So now we could use elimination and add straight down. You could also use substitution for this question by rearranging the first equation to either be q equals or n equals. So no matter which method you use, what you can end up doing and solving through elimination, you get 20q equals 220, divide by the coefficient of 20, and we find out that there are 11 quarters. Knowing that there are 11 quarters, you can go back and plug into the first equation and solve for n to find out that there are 21 nickels. So again, don't forget to put your let statement. Therefore, 21 nickels and 11 quarters. And again, whether you use substitution or elimination, whether you eliminate n or q first, your final answer will still be the same thing. Let's look at another example. And the last two examples we're going to look at are more difficult situations. So, Jim is going hand gliding. He glides 4 kilometers into the wind in 80 minutes, and he glides with the wind for 4 kilometers in 48 minutes. Find the gliding speed and the wind speed. So create your let statements and then come back. So once we have our let statements of G is the gliding speed and W is the wind speed, which you're hinted to in your last sentence, you want to come up with your equations. So because we're dealing with distance and time, we want to remember the formula of distance equals speed times time. And then we want to think about how wind will impact the distance that you travel. If you are going into the wind will push you back. So it pushes your distance back. So it will reduce the amount that you would travel in a vacuum. With the wind pushes you forward, so it would increase your distance that you would travel without the wind. So knowing that, we can create our two equations of into the wind, we travel 4 kilometers. Distance equals speed times time. So our speed is our unknown, and the time, because it's 80 minutes, okay, speed is in terms of per hour. So therefore, since 60 minutes are in 1 hour, we have to say 80 minutes out of 60 minutes for converting to hours. Again, we're going into the wind, so any distance that we travel from gliding speed will be reduced by the wind speed times the wind time, which is the same amount of time. With the wind, we'll still go 4 kilometers. We'll do it faster though. We'll do it in 48 out of 60 minutes times the wind speed, and that will be increased by the amount that the wind pushes us. So how many people like to actually deal with fractions? Let's reduce these fractions So we can see that 4 will equal 4/3 G minus 4/3 W from our first equation. And 4 will equal 4/5 G plus 4/5 W from our second equation. But again, we still have fractions. Eliminate your fractions by multiplying by the lowest common denominator. So the first equation will multiply everything by 3 and eliminate our fractions on the right side. And the second equation, we're going to multiply everything by 5 and eliminate the fractions on the right side. So our first equation will become 12 equals 4 times G minus 4 times W. And our second equation will become 20 equals 4G plus 4W. So our coefficients are the same and different signs for W, so we can add straight down and eliminate W, being left with 32 equals 8G, divide by the coefficient of 8, and G will equal 4. So now we can plug that back into one of our two equations, and we have 20 equals 4 times 4 plus 4W, and we can isolate for W and solve and get 1. So we have our therefore statement that the gliding speed is 4 kilometers per hour and our wind speed is 1 kilometer per hour. Our final example is a mixture question. So Dave is preparing his classroom for a lab. He needs 8 liters of 58% hydrochloric acid. He only has 40% hydrochloric acid and 80% hydrochloric acid. How much of each should he use to get his mixture? So this often happens in chemistry classes and preps, and that you have to create a mixture. So you could think of the 40% as sort of being red and the 80% being blue liquid. So we're going to create a mixture that's going to be 58%. So the question is, how much red do we use and how much purple do we use to have this certain tinge of purple? Well, again, if you're thinking about amounts, if you're pouring into a 8-liter container, you're going to be reduced in how much you can use of each, right? You can't use 8 liters of red and use anything of blue. You have to use something that will add up to fill your container and not overflow. So we have our let statements. Let F be the amount of 40% and E be the amount of 80%. And then we're going to write our two equations. This is very similar to our coin questions. So we'll have an amount of liquid equation, and we'll have a combinations, which will use our percents. So try and come up with those and pause the video and then come back. So we can see that our amount of liquid equation will be F plus E will equal 8. And our combinations equation is a little bit more complicated. The amount that we have of 40% will be a concentration amount of 0.40 times that amount plus 0.80 times the amount of 80% for concentration. And the key thing is that you don't want to forget about the concentration of 0.58 times the total amount that we have, 8 liters. Okay, you had a percent and an amount, a percent and an amount. So on the right side, we're going to have a percent and an amount. And we can go about simplifying these two equations. We can multiply everything by 100 on the second equation and eliminate our decimals. And therefore, we're going to have 40F. So we can multiply our top equation by negative 40 so that they'll eliminate. So when we do that, we get negative 40F minus 40E equals negative 320. And our second equation, eliminating the decimals, we have 40F plus 80E equals 464. And we can eliminate F by adding straight down, and then solve for E by dividing by the coefficient and getting 3.6. So now knowing that we have 3.6 liters of 80% hydrochloric acid, we can solve for the amount of 40% hydrochloric acid by isolating for F and getting 4.4. So our therefore statement, he should use 4.4 liters of 40% and 3.6 liters of 80%. We're going to continue to work on word problems for the next few days.